So continuing with systems of equations, we are now going to look at three variable systems of equations. So if you have three variables, this means we're going to need three equations. So if you have two variables, you need two equations, three variables, three equations, four variables, four equations. And then even then, that doesn't necessarily mean you're going to end up with solutions. We're going to do the easy version of this, and we're just going to do three variables, three equations, and we are going to have solutions. So in general, any equation of the form ax plus by plus cz equals d, where a, b, c, and d are real numbers, and they're not zero, is going to be a linear equation in three variables, which is going to be x, y, z. So our solutions are not ordered pairs, but are ordered triplets. So it's not just x, y, it's x, y, z. So solution for a system of linear equations of three variables, an ordered triplet of real numbers that satisfies all equations in the system. The solution set of the system is the set of all its solutions. So our solution set is going to be just one point. It's going to be an ordered triplet that is going to start out with the x point, y point, then the z point. So once again, we'll just run through this quickly. So we already saw that if we had a system of two variables and two equations, and we just wanted to figure out if we had a solution or an ordered pair that was a solution, we just substituted the x and the y into all my points, or into all my equations. We're going to do the same thing here. This time we have three equations, three variables, so we have an ordered triplet of x, y, and z. So if we want to know I actually have a solution, I just have to make sure that the ordered pair works for all of my equations. So really want to know is this a solution to all three equations? So not just two equations, I want to know is the solution to all three. If it's not a solution to one of them, then it's not a solution to the system. So we have x minus 2y plus 3z equals 22. We have 2x minus 3y minus z equals 5. And we have 3x plus y minus 5z equals negative 32. And my x is negative 1, my y is negative 4, and my z is 5. So I have negative 1 minus 2 times negative 4 plus 3 times 5. So this is 1. Negative 1 times negative 4 is plus 4. Then we have, that's a negative 1. We have 3 times 5, that's going to be 15. Oops, sorry, that was a negative 4. Negative 2, negative 4, that's going to be an 8. I don't know why I saw 2 there. So what we have is 7 plus 15 equals 22, which is going to be 22 equals 22. So we found that this point is a solution to x minus 2x plus 3x equals 22. So in the next equation, 2x minus 3y minus z equals 5, we have 2 times negative 1 minus 3 times negative 4 minus minus 5. And we want to know, is that going to equal 5? So we have 2 times 1, so that's negative 2. Negative 3 times negative 4 is positive 12. Minus 5 equals 5. So this is just 10 minus 5 equals 5, or 5 equals 5. So negative 1, negative 4, and 5 are a solution to 2x minus 3y minus z equals 5. 3x plus y minus 5z equals negative 32. We're going to see if that's a solution as well. So we get 3 times a negative 1 plus y, which is negative 4, minus 5 times z, which is 5, and that's going to equal negative 32. So we have negative 3 minus 4 minus 25 equals negative 32. So that is going to be minus 7 minus 25 equals minus 32, which is negative 32 equals negative 32. So it is a solution. So it's a solution to all equations, therefore a solution to the system. So when we're going to solve a system of 3 variables, you could do this with a substitution method. The problem with substitution method is that it just tends to be a little cumbersome and you get lost in it. And also, like I said, we're aiming towards a system which is going to use matrices and reduced echelon forms. And that ties in with this elimination method, or our addition method that we used earlier. So we're going to use a version of an addition method to help us solve 3 variable systems. So we are going to reduce the system to 2 equations and 2 variables. And the way we're going to do that is we usually accomplish this by taking 2 different pairs of equations and using the addition method to eliminate the same variable from both pairs. So what we mean by that is, like, let's say we have this system. So this is equation 1, 2, and 3. What we'd want to do is we're going to pair up 1 and 2 and maybe like 2 and 3. And then in either case, eliminate a common variable. So here we would eliminate, say, x. If I did it here, then I want to eliminate x here. So whatever it is, just make sure you pick the same one. So we want to put 2 different equations together, like 1 or 2, 2 and 3, or you could have had 1 and 3, just as long as we got 2 different combinations. And we want to eliminate a variable from both of them. So that is going to give me 2 equations and 2 variables. So the next part is we're going to solve the resulting system of 2 equations and 2 variables by using addition or substitution. I'm going to do this all with addition. You could do substitution if you wanted to. But we're doing what we usually do in math is we take something that was a little more difficult and brought it down to something we're familiar with. So we have 3 variables, which we turn into a 2 variable system, which we know how to solve. So the result of this 2 variable system is we're going to find one of our variables, and then we're going to go back to back substituting and find the remaining variable from the 2 system. At that point, we have our 2 variables. So we just use the 2 variables that we have to go back with one of our equations and find the 3rd variable. And at which point we are going to just check to make sure we have the right solutions. So because this is going to be very, very cumbersome and time consuming, I am not going to be checking solutions constantly. I've already checked these solutions for us, so I know that they are the correct solutions. Okay, so like I said, this is going to be cumbersome. It's not necessarily difficult, it's just a lot of work, which is going to make us much more grateful when we get into doing matrices. That's going to help us with this a little bit. So we're going to call these equations 1, 2, and 3. So we need to make a decision first. What do we want to try to eliminate first? We want to try to eliminate z or y, or sorry, x, y, or z. So for me, what I noticed here is that I have y. So if I doubled this, I'd have a 4y to counter that. But I have a 3y here, so that's going to make this a little difficult. I got a 2 and a 3 and a 1 here. So if I like tried to do some doubling, it's just looking at my variables and trying to make a decision which might be easier to use. So since I have a negative z, a positive z, and a 2z, all I have to do here is like multiply by a -1 or a 2, and I can start eliminating z's. Like I said, you could pick any variable. It's just my thought process here. So I'm going to choose to eliminate z first. So that's my first step, is always just pick a variable that you want to use. It's not really going to make a big difference. It's just, is it going to make life easier for you? So what you're going to do is you're going to pick a combination of two equations. So I'm going to do 1 and 2. So x plus 4y minus z equals 20. And then I have 3x plus 2y plus z equals 8. Now, if I add those together, I'm going to eliminate z instantly, and I'm going to be left with 4x plus 6y is going to equal 28. And we're going to call this a new equation. This is going to be equation 4. Now, I just need to pick another pair. So I'm going to pick 1 and 3. So 1 is my x plus 2y minus z equals 20. So all that matters here is that I picked 1 and 2 here. I can't pick 1 and 2 again, but I can pick 1 and 3 because it's a different pairing. And then I'm going to have my 2x minus 3y plus 2z equals negative 16. So if we want to eliminate z, what I'm going to have to do is I got a negative z here and I got 2z. So I'm just going to multiply everything up here by 2. So my new set of equations are going to be 2x plus 4y minus, oops, I should do all the math involved there. 2x plus 8y minus 2z equals 40. And the bottom one didn't change. That's 2x minus 3y plus 2z equals negative 16. And when I add those together, I'm going to end up with a 4x plus 5y. The z's are gone, and that is going to equal 24. And I'm going to call this equation 5. So now we have two equations in two variables. We have equation 4, which is my 4x plus 6y equals 28. And I have my equation 5, which is my 4x plus 5y equals 24. And all we're going to do from here is we are going to solve for x and y. So we already know how to do this part. So we have a 4x and a 4x. So if I multiply, just pick one of these. Let's multiply this all by -1. We are going to have new set equations here. There are going to be 4x plus 6y equals 28. And then we'll end up with negative 4x minus 5y equals negative 24. When I add those together, the x's are gone, and I'm just left with y equals 4. So I have part of my solution now. So I'm going to make a little spot up here because at some point we're going to have to do some erasing because this is going to take up a lot of space. So we know at least that y is 4. Now that we have one of our equations, all we have to do is go back, and let's say we pick 4, and we're going to solve for x now because we have y. So 4x plus 6, and y is 4, plus 24, is going to be 4x plus, okay, make sure I was getting that right. 4x plus 24 is going to equal 28. So 4x is going to be equal to 4, which means x is going to be equal to 1. All right, we're getting all the right solutions so far. That was the hardest part of all of this. So our very last bit of this is we know that x is 1, we know y is 4, so we just want to solve for z, and we just want to pick one of our equations. So I'm just going to pick the top one, my x plus 4y minus z equals 20. We said x is 1. We said y is going to be 4, so we just have to figure out what z would be. So this is 1 plus 16 minus z equals 20, which is going to be 17 minus z equals 20, which is going to be minus z is going to equal 3. Second is something in my way here, which is going to be z is going to be equal to minus 3. Okay. And like I said, I had already pre-checked all these. So x should be 1, y should be 4, and z should be negative 3. So what I'm going to say, sorry, my stuff keeps getting sticking here. The solution to the system of equations is an ordered triplet, and we're going to write it x first, so 1, then y, which is 4, and then z, which is negative 3. So that is our solution right there. It's the ordered triplet 1, 4, negative 3. If you can, take a minute and just try what you can, but we'll go through each one of these. We have 1, 2, 3, and 4. So just take a chance on all these. These are different situations that you might see. And for one of them, second, I'm checking here. I believe it is 4. 4 is going to give you fractions. So 1, 2, and 3 should be integer solutions, and 4 should be fractions. So rational numbers, just so you're prepared for that. But just do what you can, and then we will run through it together. We may not all solve this the same way, but what's important is that we get the same solutions. Let me make our space here. So for number 1, we have these 3 equations. So once again, we're just going to call them equations 1, 2, and 3. And what we're trying to do is treat equations 4 and 5, which are going to be 2 variables, but they're the same 2 variables. So I need to decide what I want to eliminate first. So when I did this one, I decided I was going to try to eliminate x first. So sometimes you want to eliminate a variable and additional variables go with it, which happened in this case. So I used equations 1 and, just double check that, 1 and 2 are the ones I paired together. So that was x plus y plus 7z equals 22, and x plus y plus 9z equals 30. And like I said, I decided I wanted to eliminate x first. So I just multiplied the bottom by a -1, so I'd have an x minus an x. So x plus y plus 7z equals 22. Negative x, negative y, negative 9z equals negative 30. So when I added these, x minus x, that disappeared. Y minus y, that disappeared. And then I had a negative 2z, and then that was equal to negative 8. So I was left with negative 2z equals negative 8, which is just z is equal to 4. Because z is 4. So we already have one of our variables. So we'll still keep doing the same thing because I still need to use the other 2 to figure out another equation that I might have. So in this case, I used 2 and 3. So like I said, just as long as it's a different pair. And once again, I said I was going to eliminate x because that's just what I picked. So if I want to eliminate x, I have to multiply one of these by a negative. So the bottom one, I multiplied by a -1. So we're going to go down here because I ran out of room. So that's going to give me x plus y plus 9z is equal to 30. And then we have negative x plus 9y plus 5z is equal to -24. And when I add these together, I'm going to end up with 10y plus 14z is going to equal 6. So these are my two new equations. So this is equation 4 and this is equation 5. Just happens to be one of the equations is just z equals 4. So I already have z. I just want to, at this point, make a little room here. We're going to use 4 and 5 to solve for y now, because that's what I can do. So I know that I got 10y plus 14, and that z we said is going to be 4, so that's 14 times 4 equals 6. This is 10y equals 14. I was trying to find it on here. So 14 times 4 is 56, which equals 6. So if I subtract a 56, that's 10y equals -50. So y is equal to -5. Now we just have to go back and figure out what x is. So like we did before, just pick one of your equations. Which should be easier? Let's use one. Use one to solve for x, my remaining variable. So I have x plus y plus 7z. Let's fix that. I said z. 7 looks like it's z. 7z equals 22. We got x plus -5 plus 7 times 4 equals 22. So what we have here is x minus 5 plus 28 equals 22. And what that ended up being is that is going to be x plus 23 equals 22. So when we solve for x, x is just going to be -1. So my solution is the ordered pair -1, -5, 4. Okay, so I tried to eliminate z first. I did try eliminating x first. So let's eliminate y now. So my equations, once again, I'm going to have equations 1, 2, and 3. And I want to eliminate y first. So the reason I did that is because I had, once again, I had a y and a y. So all I have to do is multiply one equation by a negative, and that's easy to take care of. I'm just trying to make life easier on myself is all I'm trying to do. So the combination, I used 1 and 2, I think. Yes, 1 and 2. So we have 7x plus y plus 5z equals 27. And then 2 is going to be the 4x plus 3y plus 5z equals 21. So I have a 3 here and I have a 1 here. So all I did is just go, hey, if I want to get rid of y first, let's multiply everything by a -3. So I have a -3 and a +3 to cancel out. So this is -21x minus 3y minus 15z. And 27 times 3 is going to be, or negative 3 is going to be negative 81. Then we have 4x plus 3y plus 5z equals 21. So when we add that together, we end up with a negative 17x minus 10z equals negative 60. And this is equation 4. Since I'm going to use it here in a second, we'll put 4 back down here. So we got an equation in 2 variables. Now I just want to make sure that I get another equation in the variables of x and z. So I'm going to use 2 and 3. It has to be used 2 and 3. So because I always used 1 and 2, I have to use 1 and 3 or 2 and 3. So use 2 and 3, so that is going to be 4x plus 3y plus 5z equals 21. And then we have 6x plus y plus 2z equals 9. So move something out of my way here. And what we want to do is eliminate the y's again. So I'm going to just multiply this one by a negative 3. So I'll have a plus 3 and a negative 3. So that's going to leave me with 4x plus 3y plus 5z equals 21. And then I'll be negative 18x minus 3y minus 6z equals negative 27. Actually, let me write this all down here. Just because I'm running out of room. 4x. That's the worst part about this. It's just this space it takes to write these problems. Negative 18x minus 3y minus 6z equals negative 27. Okay. So we add those equations together. So 4x minus 18x will leave me with a minus 14x. 3y minus 3y, that disappears. 5z minus 6z is going to leave me with z. And then 21, sorry, that should have been a 7. 21 minus 27 leaves me with negative 6. And this is my equation 5. So there's 4, and here's 5. So we want to solve these for x and z, which is what I can solve for. So we see that probably the easiest thing to do is already got a 10z and then a negative z, is we're just going to multiply this by a negative 10. So this becomes a plus 10z, and they cancel. So we're going to end up with a negative 17x minus 10z equals negative 60. And then a positive 140x plus 10z is going to equal negative 60. Oh, no, positive 60, sorry. So we've got negative 10 times a positive 6. So when we add these together, we're going to end up with negative 17 plus 140x is going to give us 123x. Our z's are gone, and we're going to get minus 60 plus 60, so that equals 0. So 123x equals 0, meaning x is just going to be 0. So we have one of our variables now. So we have that x would be 0. So I'm going to have to go over here and take out some of my space so I can finish this problem. So let me get this over here. We're going to just get rid of this and leave us some room here. So now what we're left with is we've got one of our solutions. We got 2 equations. So let's just pick this one here. So we just need to solve for z now. So we know that negative 14x minus z equals negative 6. And we just said that x has to be 0. So that means that we have negative 14, 0 minus z equals negative 6. So we're getting negative z equals 6, which means z is going to be 6. So now we just have to figure out what y is. Okay. Sorry, I'm going slowly, give you kind of some room here, time here before I put this back up here. Now my last bit here, just pick one of the equations. Let's pick one, it's on the top. So we're going to pick one. So that is 7x plus y plus 5z equals 27. And we know that x is 0, and we know that z is 5. So we have 7x plus, 7x. We have 7 times 0 plus y plus 5 times 6, and that's going to equal 27. So we're left with, this is going to be 0, so it's just y plus 30 is going to be equal to 27. So if I subtract 3 from both sides, y is going to be equal to negative 3. So my solution is going to be 0, negative 3, and 6. So don't let that throw you off having, like I said, 123x equals 0. That just means that x has to be 0. That 0 can be a solution to one of your variables. Which is we have a tendency when we see zeros think that we did something wrong, and we didn't necessarily do anything wrong. Okay, so 3 here, halfway through. So 3, a second, there we go, trying to get my writing tool and it wasn't showing up. Equations 1, 2, and 3. So, doesn't seem to be there's any real advantage to doing x, y, or z eliminating it first, so we'll just eliminate x. Okay, so when I eliminate x, I'm going to use equation, looks like I'll do 2 and 3. Why not? So that is going to be negative, let me give myself a little space here, negative 4x sorry, that was me after I duplicate it. This is going to be 2x minus 4y plus 2z equals 12. And then we're going to have 4x minus 5y plus 4z equals 15. So if we're trying to eliminate x, we already have a 4x here, we have a 2x, so I just need to multiply by minus 2. So that means we're going to have a minus 4x plus 8y minus 4z equals negative 24. And then the other part's going to stay the same because we didn't change anything. So that's just 4x minus 5y plus 4z equals 12. We add those together. Minus 4x plus 4x. My x's are gone. 8y minus 5y is 3y. And 4z plus 4z, so that happened again. We end up with 0z. And negative 24 plus 12, 15. Just saw there's a typo there. So he's using equation 3, I accidentally used equation 2. That's a 15. So this is one of the things, I'll be honest, that you're going to probably struggle with is just making little mistakes like that and just trying to catch them. So negative 24 plus 15 is negative 9. And if it makes you feel better, one time I was trying to solve one of these and I made a mistake 3 times and spent 30 minutes trying to solve a system of equations because I just kept making little silly mistakes. So silly mistakes are going to happen. So we're left with 3y equals negative 9, which means y is just going to be negative 3. So let's pick another pair of equations. like I said, sometimes we just get lucky and we eliminate multiple variables at once. So use equations 1 and 3. Sounds good. So I'm going to do 3x plus 4y minus 3z equals negative 18. And then we are going to have this one, 4x minus 5y plus 4z equals 18. And I said I want to eliminate x first. So we have a problem here. I'm going to actually have to multiply both of these by a number. So we got a 3x and a 4x. At best, I can get a 12x. So I just need to make sure that I get a 12x and a minus 12x. So if I distribute 4 times 3x, that is going to be 12x plus 16y minus 12z equals 4 times negative 18 is negative 72. The negative 3 times 4 is going to be negative 12x, and then negative 3 times negative 5 is going to be plus 15y, negative 3 times 4, negative 12z, and that is going to be negative 3 times 5, negative 45. So don't let this fool you. That's a negative 12z and a negative 12z. The x's we lose. The y's, we get 16y plus 15y, so that's 31y. And then here, that's negative 12z, negative 12z, so that's going to be negative 24z. And then minus 72 minus 45 is on minus 117. So this is my second equation. So this is equation 4, and this is equation 5. Now we have 4 and 5. And we're going to use those to figure out our variables. So we already know that y is negative 3. So we're just going to solve for z, which I can find. So I got 31, and we said y is negative 3, so 31 times negative 3 minus 24z equals negative 117. So 31 times negative 3 is negative 93 minus 24z equals negative 117. If I add 93 to both sides, that's negative 24z is equal to negative 24. And we get that z is going to be 1. So we have our solution partially set up. We don't know what x is, but we know that y is negative 3, and we know that z is 1. So we just need to find x now. So as we said before, we just pick one of our equations, 1, 2, or 3. Trying to think of just one that's a little preferable here. I'm not sure there really is. So we just need to find x, right? So let's use equation 1 because it's not going to make a difference. So we're going to use 1 and that. Sorry, my thing is starting to wear out here. Y is negative 3 and z is 1. And we're going to solve for x. So we have 3x plus 4 times negative 3 minus 3 times 1 equals minus 18. So we got 3x minus 12 minus 3 equals negative 18. So that is going to be 3x minus 15 equals negative 18. Or 3x is going to be equal to negative 3. And we get that x is just going to be negative 1. So my solution is x is negative 1, y is negative 3, and z is positive 1. All right, so our last one, we have an interesting set of equations. We have 5x plus y equals -5. So we have an equation that's only two variables, but we see that we have two more equations that do have x, y, and z. We have x plus y minus 5z equals -4, 3x plus 3y plus z equals 0. Okay. So we just need to find a system of equations in two variables. And actually, the easy way to do this is we already have, like I said, one equation in two variables. We're going to have equations 1, 2, and 3. And this one, already two variables, which are x and y. So that means I just need one other equation, an x and y. So I'm going to put equations 2 and 3 together to get this new equation. Because I'm already using one here as my one equation, I can't use it again here. So I need to make sure I use the other two to find another equation in two variables. So x plus y minus 5z equals -4, and 3x plus 3y plus z equals 0. So the easiest thing to do is, well, not necessarily the easiest. So we need, second, let me look here. Because we have x and y, what we need to do is we need to eliminate z. So we're going to multiply this bottom one by 5 because then I'll have -5z plus 5z. So we're going to have x plus y minus 5z equals -4. And on the bottom, we'll have 15x plus 15y plus 5z, and 5 times 0 is still 0. So when I add that together, I end up with 16x plus 16y, and that is going to equal -4. So if you wanted to at this point, like I said, this is my new equation, 4. We could simplify this. Everything's divisible by 4, so you could say that it's just 4x plus 4y equals -1, just to make life a little easier on us. Okay. So we're going to use 1 and 4 to find x and y. So we have 5x plus y equals -5, and we have 4x plus 4y equals -1. So if I just take the top one and I multiply by a -4, we're going to make this a little easier for us because then we'll have a -4y and a +4y. So we're going to end up with -20x minus 4y equals 20. Second, my thing is messing. There we go. And then we're going to have 4x plus 4y equals -1. So we add those, we end up with a -16x is equal to 19. And we can end up with x is just -19/16. So it may not be an answer we like to see, but it's the answer we're going to get here. So now we go back, we found x, so now we just have to find y. So we have 5x plus y equals -15. So if I just replace that with 5 times -19/16 plus y equals -5. 5 times 19 is going to be a 95, so this is -95/16 plus y equals -5. So you're going to end up with y So you can change this because this is 16 here. So -5 is just going to be -80 over 16. And then we just added 85 or 95 over 16. So y ends up being a 15 over 16. Now the last bit that we have to do is we just need to find our remaining variable. So we have x, we have y, and we just need to find z. So we have this x plus y minus 5z equals -4. So then we don't have to worry about any kind of fun multiplication here. So we have x is -19 over 16, y is 15 over 16, minus 5z equals -4. So this is going to be -4 over 16 minus 5z equals -4, or -1/4 minus 5z equals -4. So we get -5z is going to be equal to, we can change this -4, so it is a -16 over 4, and then we are adding the 1/4 from the other side. So we end up with -5z is going to be equal to -15 over 4. And if I divide both sides by 5, that is, or -5, that is going to be z is going to be equal to 3/4. So here, my solution. Remember, it has to go x, y, z. The solution is going to be -19 over 16, 15 over 16, and then our z, which is 3/4. And all those are reduced fractions.